yesterday also I have told you that the complex exponential signal is doing. Just wait. This is the complex exponential signal e to the power j omega 0 t. In last class, what you have seen that xt equal e to the power minus alpha t. There are no j or I. You have studied in your 12th standard. So the complex means you should here we shall use the j. So xt j means what is j? Root over
minus 1.
minus 1. So this j xt equal e to the power j omega 0 t. Now if it is repeating, then it should be xt plus t equal xt. Any doubt?
No, sir.
Okay. Then xt should be equal to the xt plus t. Let us prove that one. Say put the t equal t plus t in this equation. X t plus t equal e to the power j omega 0 t plus t, and multiplied it, and we shall get this one e to the power j omega 0 t e to the power into e to the power j omega 0 t. Now put the value of this omega 0. What is the omega 0? Omega 0 is the twice pi by t. Twice pi by t. Here your period is you are considering capital T. This capital T within the twice pi, that is twice pi of t, that is your frequency. So here we put the omega 0 as twice pi by t, and you will get this one e to the power j of twice pi. 1 upon t and capital T will be eliminated, and you will get e to the power j twice pi. So e to the power j omega 0 t into e to the power j twice pi. Here, this one you can write in trigonometric formula from the Euler's formula to trigonometric formula e to the power j omega 0 t. If you take this one common, then 1 plus or cos twice pi plus j sine twice pi. We can write this one. Can we write? Yes or no?
Yes, sir.
Okay. Then cos twice pi means 1 and sine twice pi means 0. So this will go 1 plus 0 within this third bracket. It is 1 plus 0. So 0 into this part is not there, and this part is e to the power j omega 0 t. That is xt equal e to the power j omega 0 t. That is xt. So this xt plus t equal x t. Okay. So we can say that the complex exponential signal, the exponential signal is not repeating. It is an aperiodic signal, but the complex exponential signal is a periodic signal. It will repeat. So our transformation or synthesis or analysis, we shall consider the periodic signal. The periodic signal. So this complex exponential signal is a periodic signal. So we should consider this one later on. Okay. Now the signal, I have told you that basically two types: continuous time and discrete time. The discrete continuous time, that is you have studied and you have seen all the signals that is generated in the nature, all these signal are continuous time signal. And the discrete time signal can be expressed in different four ways: the graphical method, functional mode, tabular mode, and sequential mode. Okay, graphical mode, that is graphical representation. Functional mode. Suppose we are writing xt. We are writing xt, that is continuous time. In discrete time, it should be xn. In first class, I have told you in discrete time, we should write instead of t, we should write n. So here the functional mode, it should be xn. And tabular and sequential, let us discuss all the things today. This one is the graphical mode. Means we have considered this one, we have considered, suppose this is your x-axis, this point is 0, at 0 it is 1, amplitude is 1, minus 1, amplitude 1, minus 2, amplitude 1. At 1, what there? So at 1, it is 2, at 2, it is 2, at 3, this one is 1. Clear?
Sir, xn is signal.
Huh?
If xn is signal.
Xn is the same function. Xn is the function. This function, basically, if it is in continuous form, it is xt. In continuous form, it is xt. But in discrete form, you should write this one xn, as because your time period is not continuous. It is in instant of time. Here minus 2 to minus 1, in between minus 2 to minus 1, in continuous time there should be a line. It is continuous. Your signal is xt plus del t. The increment of del t increment always there you will get in continuous time signal, but in discrete time signal in instant of time. That time we have considered at 0 and plus minus 2 or 3, whichever it is. We are considering here. Then the signal in graphical method, this will be like this. Here the amplitude is 1, here 2, 2, 1, 1, 1. Is it clear? This method is called graphical method. Your signal you can express in graphical method, and your continuous time signal also you can express in graphical method. And functional method, here xn equal 1 when n equal minus 2, minus 1, 0 and 3. Okay, and xn equal 2 where n equal 1 and 2. It is by mistake the 2 is not written here. There should be n equal, you should write n equal 1 and 2. At 1, this is the amplitude 2. At 2, the amplitude is 2. So n equal 2. The value of n, this value of n, these are the value of n. Minus 2, minus 1, 0, 1, 2, 3. All these are value, these variables n. Variable, these values are this one. These values are this one. So this is the graphical method and this one is the functional method. Clear? Or any doubt?
Clear, sir.
It is clear. So if the functional method, if any signal is given to you, you can write this one in graphical method. Can you write?
Yes, sir.
Okay. So you can write this xn or the functional method mode, you can convert it into graphical mode. Now the tabular mode. This tabular mode here, these are the value of n. We have put the value of n -2, -1, 0, 1, 2, 3. All these are the value of n. And xn, these are the amplitude. At -2, this is 1. At -1, this is 1. At 0, this is 1. At 1, it is 2. At 2, it is 2. At 3, it is 1. So this function or this signal can be expressed in tabular form, can be expressed in functional form, and another one is the sequential form that is more important. The sequential form is not written here. Anyway,